Hey guys, welcome back to another RSK Maths video, and in this video I'm going to be showing you guys a crazy trick which you can use to find the sum of all of a number's factors. So I've given you guys an example question here, which is to find the sum of all of 60's factors, but the trick I'm going to show you guys can work for basically any number, so it doesn't have to be 60. I just picked 60 because it's a pretty small number but still has a lot of factors. Okay, so the trick relies heavily on the idea of how we generate factors, and I've made a video on this previously, so I might link it below or just search up how to generate factors. But basically what we need to do is first we need to write the number in its prime factorisation form. So 60, we know that's the same as 12 times 5, and that's the same as 2 squared times 3 times 5. So here is 60's prime factorisation. Now from here, what we need to do is we need to figure out all its factors, and the way we could do that is using the prime factorisation trick. So to figure out its factors, we need to get all the possible combinations of its factors and its prime factors and their powers. So for example, these are all the possible forms of 60's factors. And we just need to get all the possible different combinations from each bracket. So it might be 2 to the 0 times 3 to the 0 times 5 to the 0. There's one factor. Then we have 2 to the 0 times 3 to the 0 times 5 to the 1. Then we might have 2 to the 0 times 3 to the 1 times 5 to the 0. And this process just continues like so until we've eventually got through all of the factors. And this is also a quick way of counting the number of factors a number has. So you can see that this set has 3 items and each of these have 2. So in total there's going to be 12 different combinations, and therefore 60 will have 12 different factors. If we wanted to find all those factors individually and sum them all, that's going to take ages, but there is a much faster way. So you might have noticed a pattern in these sort of these factors, and it all comes down to how we're trying to find every single combination of these brackets. And this is similar to how you expand brackets in algebra. So let's just say we had like x plus, well, let's have x to the 1 plus x to the 2 multiplied by y to the 1 plus y to the 2. This basically allows us to see all the different combinations of x and y. So we can get x to the 1 times y to the 1 plus x to the 1 y to the 2 plus x to the 2 y to the 1 plus x to the 2 y to the 2. So you can see this gives us every single possible combination within these brackets, because that's inherently how you FOIL out brackets. And this relates to generator functions, which I'll make a video on in the future. But what I'm trying to show you guys is if we set up the brackets so that they have these factors going up like so in each bracket, then when we expand it, we're going to just end up with all of the factors of 60. So let me show you what I mean. We can have 2 to the 0 plus 2 to the 1 plus 2 to the 2. There's our first bracket. Multiply that by 3 to the 0 plus 3 to the 1. And multiply that by 5 to the 0 plus 5 to the 1. And now you'll see, when we expand out this entire thing, so I'll just do a bit just to give you guys the idea. So let's just say we have, okay, so let's just start off with this pair and then that pair. So we go 2 to the 0 times 3 to the 0 times 5 to the 0 plus 2 to the 0 times 3 to the 0 plus 5 to the 1 plus 2 to the 0, 3 to the 0, sorry, 3 to the 1, 5 to the 0 plus 2 to the 0, 3 to the 1, 1. And then we do the same thing, but with 2 to the 1, 3 to the 0, 5 to the 0, and just continue this on. And you see, we'd end up getting every single combination within these brackets. And that would give us all of the different possible factors of 60, all the way up to 2 to the 2 times 3 to the 1 times 5 to the 1, which is indeed 60 itself. So this here is actually the sum of all of 60's factors. There we go. So now you can see we've got it in this form, but we've also got it in this form. And this form is going to be a lot easier to calculate. So if I bring this bracket down here, you can see I can pretty easily calculate it by first just simplifying each of the brackets down. So we could get 2 to the 0 plus 2 to the 1 plus 2 to 2. That's the same as 1 plus 2 plus 4 times 1 plus 3 times 1 plus 5. And that is the same as 7 times 4 times 6, which is the same as 24 times 7, which is 168. So you can see here, that is the answer. That is the sum of all of 60's factors. And it actually gets better from here. That was pretty good, but there's one more extra thing which just makes it even better, is the fact that these are geometric sequences individually. So if this was like, let's say we had a number which had 2 to the 7 in it, it would be quite difficult and unreliable to try and sum those 7 numbers. So what we could do instead is just use the fact that this is a geometric sequence and use the sum of geometric series formula to actually work out what each of these brackets is. And then we just multiply them together. So that's a super fast way of finding the sum of any number's factors. I've used 60 here, but if this was a different number, then what you do is just split it into its prime factorisation, then just put them in brackets so that it starts from 0 and goes up to whatever the max power of that number is. Multiply them all out, and then this form is easy to evaluate, so we can easily work out what the sum is, which is 168 in 60's case. Anyways, thanks for watching, and I just wanted to show you guys this crazy trick. See you guys in a future tutorial. Bye.